Okay, let's take a look at finding the derivative, and we're going to focus right now on some special cases. Now, there are a lot of these, but these are kind of the five that I find are maybe the most common to see. They're also on the easier side, but they're really good ones to know because they come up the most often. So, those are that when f of x is sine of x, it becomes cosine of x. Cosine of x, the derivative is negative sine of x. So if this is negative, that would turn positive. And then tangent of x becomes secant squared x. So those are the trig derivatives. And then e to the x is the only one that actually doesn't change, and that has to do with the slope of the tangent line being the same as the actual function due to its nature as an exponential function. So e to the x is still e to the x, so that one doesn't change. And then natural log of x becomes 1 over x. Okay, now if there's a number in front of that, it would be different, but we'll look at some examples. Okay, so let's try finding some derivatives where we have special cases. Okay, now when I look at these, right, I'm given this f of x as negative 2x to the fifth plus 3 cosine of x minus 4e to the x. So what I'm going to do is I'm just going to divide this into really three parts. I'm going to take the derivative of each term here, and then I'll be done. Okay, so f prime of x is going to be, we're going to use the power rule here. We're going to say negative 2 times 5 is negative 10. Subtract 1 from the exponent, and now I have the derivative here. Now, cosine of x, remember, becomes negative sine of x, so that 3 is going to turn negative, and we have negative sine of x. And then remember, e to the x is the only one that doesn't change. So also the coefficient in front of it will not change either. So this one's pretty easy, one step, and we're done. Let's go on to the next one. So now we have three different special cases here, but like I said, we're going to treat each one individually and find our answer here. So if we want to find the derivative, this one is going to become the negative 5 does not change, and we're going to have secant squared x. And then remember, the derivative of sine is just cosine. There's no sign change. Positive or negative, it doesn't change. So we have this. Now remember, this becomes really, it's negative 5 when we take the derivative of 1 over x. But we could also just write that easier, is just write it as one fraction, negative 5 over x. Okay, so if you have something other than 1 here, you're just going to put that in the numerator, and you have negative 5 over x. Okay, let's keep going. Next two, we're going to have a little more work here, but they're fairly easy ones. So if we look here, okay, we're going to divide. Now we got four terms, right? So let's divide it up and just do each part individually. We got negative 18 sine of x. We'll take the derivative, and that's just going to be negative 18 cosine of x. This one, remember, is going to become 1 over x, but it's times 6. So it's going to be 6 over x. And then remember that negative 4e to the x, that doesn't change. And then here we need to do the power rule, right? So let's just do it over on the side here, and then we'll write our final answer over here. Well, that's going to be, we're going to bring that 3 over 2 down and multiply it. And then we're going to subtract 1 from here. Well, 3 halves minus 1 is really like saying 3 halves minus 2 over 2, which will leave you with x to the 1 half. So how would this simplify? Well, not a lot, right? It's just going to be 5 times 3 over 2 x to the 1 half. So now I can write my final answer here. You could write 7.5, or you could just leave it as an improper fraction. Works fine, especially for calculus. So we have 15 over 2 times x to the 1 half. And now we have our derivative here. Okay, let's look at one last one here. So we have two special cases here, and then we have the power rule, but with a negative exponent. Okay, so this first one is negative 6 cosine of x, so that's going to turn positive, because remember, the derivative of cosine of x is negative sine of x. So that's going to be positive 6 sine of x. Now, here's another one that doesn't change. We could write this a little different, or you could just write it the exact same way, but it's e to the x over 4 is still going to be e to the x over 4. The only other way you could write this is 1/4 e to the x. That means the exact same thing. I tend to just leave it exactly as it is because it's e to the x. Okay, and then the last one, right? Well, we're going to do just the same thing, but we have a negative exponent here. So you know, and when we subtract 1, it's going to make it -4. But first, we'll bring down the -3, multiply it by 5, which is going to give us 15. And then -3 minus 1 actually leaves us with -4. Now, for calculus, you can leave it just like this, because if you needed to take the derivative again, it's easier if you just have it as a negative exponent. Okay, now we're done with this one.